Hey champions, today we're going to solve this question together. We're going to find algebraically the exact value of x if 4 to the power x plus 1 is equal to 2 to the power x to the power 2. There's a fair bit going on with this question. We're going to use a number of skills to help us here, but the main ones I've listed here on the left. We're going to need to know a few tricks around solving exponential equations. We're going to need to know a little bit about factorising, specifically completing the square, and we're going to need to know how to solve equations using the null factor law as well. Alright, so I'm going to start with my first line of working out, which is just going to be to write down the expression. So 4 to the power x plus 1 is equal to 2 to the power x to the power 2. Okay, one little trick with solving exponential equations is to make the base the same on both sides of the equal sign. So I'm just going to note here that 4 to the power, well, sorry, not 4 to the power, the actual numeral 4 is equal to 2 to the power 2. So my next line of working out, I'm going to replace that 4 with 2 squared. And it's still to the power x plus 1. So I haven't changed the value of that in any way. I've just written it a little bit differently. And that's equal to 2 to the power x to the power 2. Okay, now I'm going to expand this bracket using a little bit of index laws. So now I'm going to have 2 to the power 2 bracket x plus 1 on the left. And I've still got 2 to the power x to the power 2 on the right. Okay, so what I've done there with a little bit of rearranging, on the left-hand side I've said 2 to the power 2x plus 1 is equal to 2 to the power x squared. So we've got, if they're equal to each other, we know that the powers that each of those 2's have been raised to must have the same value. So now we can say, therefore, 2 bracket x plus 1, so what I have in the power on the left-hand side, is equal to what I have in the power on the right-hand side. Okay, so now we've made a bit of progress with this question, but we've kind of changed the type of question that it is. We've made it into more of a solving quadratics type situation. So now I'm going to expand the bracket on the left. I've got 2x plus 2, and that's equal to x squared. I'm going to make everything on the left-hand side equal 0. And the way that I do that is that I take 2x away from both sides, which will make the 2x on the left disappear, and I'm going to have negative 2x on the right. I'm also going to take away 2 from both sides, which will also give me a negative 2 on the right-hand side. Okay, so now I need to find what values of x are going to give me a result of 0. So I need to know about the null factor law, but I also need to be able to factorize this first. So looking at this quite casually, I think, well, maybe I can factorize by using the normal easy technique for monic trinomials. I can't for this one because there's no numbers that multiply to give me negative 2 and add to give me negative 2. I can't factorize by grouping. I can't do difference of perfect squares. So what I can do instead is complete the square on this one. So I'm going to say 0 is equal to x squared, take away 2x. I'm going to half negative 2 and square it, which is going to give me 1. I'll then take that 1 away. So if I'm adding 1 and taking 1 away, I'm going to keep that same value on the right, as well as bringing down that negative 2 that's up the top there as well. Okay, that allows me to factorize this expression. So the numbers, when multiplied together, will give me negative 2 and will add, will add to give me negative 2 and multiply to give me positive 1. Are going to be negative 1 and negative 1. So that factorizes to x take away 1 squared. And then I need to take away 1 and take away 2 as well. So there I've got 0 is equal to x take 1 squared, and I'm going to take away 3 from that. Now my next part of factorizing by after completing the square is kind of forcing it to play within the rules of difference of perfect squares. So now I've got x take away 1 squared, take away the square root of 3 squared. Because if I square the square root of 3, I'll have 3. So that's still the same value. But what it means is I've got a square expression take away another square expression, meaning I can factorize like this. So I've got x take away 1 take away negative 3. I've also got x take away 1 plus, not negative 3, sorry, the square root of 3. Square root of 3 there as well. Okay. So this means I can use the null factor law just here. I can say, therefore, if I look at my bracket that's on the left-hand side just here, if I can make that bracket equal 0, it makes the whole expression equal 0. So what value of x will that be? Well, the value of x would need to be the same there as 1 plus the square root of 3. Because if I take that expression, and then in place of x, I add 1 and add the square root of 3. It's going to be equal to 0. If I did that to the expression on the right, it would be x equals 1 subtract the square root of 3. Because on the right-hand side, we'd have to add 1, but take away that square root of 3 to make that part of the bracket equal 0. You'll sometimes see that written as x is equal to 1 plus or minus the square root of 3. Either of those answers is fine. And I'm going to say there that I've used the null factor law as well. Okay, so looking back at the question, we were asked to find algebraically the exact value of x. When you see exact value like that, the exact value might happen to be x equals 2 or x equals 3 or whatever, but don't be put off if you get an answer like the one that we have there. 1 plus or minus the square root of 3 is an exact value, so don't be put off by it looking a little bit scary. And this is also a good example of when you've learnt about index laws and exponential equations and factorising and completing the square. This is a nice question that draws all of those skills together and might give you a nice little challenge. Thanks.